Hello students, welcome back. Now we are going to talk about light sensitive circuits. These circuits have a device which is going to change the output value based on the intensity of light falling on the surface. So that is called light dependent resistor or LDR. It is a simplest sensor to detect the intensity of the light. This is available in a circular shape on the top, and where we have a semiconductor material called cadmium sulfide. There are two electrodes just like a resistor, and in size also it is slightly bigger than a resistor. LDR are available in the larger sizes also. When the light falls on this circular surface, the resistance offered by the LDR is going to change. If you have more light intensity, it will be less resistance, few kilo ohms, and if the intensity is very low, that means there is more darkness, then the resistance will be very high in hundreds of kilo ohm and maybe in mega ohm also. That means the resistance offered by the LDR is inversely proportional to the light intensity. So how does LDR work and how do we use it in our circuits? Let us check it on Tinkercad directly. So in the Tinkercad library, if you scroll down, you will find a photoresistor here. LDR is also called photoresistor. So I am going to just pull it, and then I need to first check that what is the resistance being offered by this device. So let me take one multimeter also, and I am going to set this in the resistance mode and just connect the two wires to the two terminals. Whichever is positive negative does not matter, because for a resistor there is no polarity. So when I start the simulation, it is showing that the resistance is 180 kilo ohm. Now how do I change the light intensity around this LDR? Just click on the LDR, and let me get this little away. So this is here, and I start the simulation. Now you can see this is on the darker side. If I move it towards the sun, that means more light, the resistance is decreasing. And if I bring it to the maximum brightness, this is 506 ohm. Somewhere in the center, the value is around 900 ohm or 1 kilo ohm. So this is very important. Whenever you choose any component, any sensor, first of all you should see what are the range of values that it is providing. So now I know that this LDR is going to give me resistance from 500 ohm to 180 kilo ohm, and at the center it is around 900 ohms or 1 kilo ohm roughly. So how does this LDR work for a light sensitive circuit? LDR alone cannot do much. We need another resistor in series to make a voltage divider circuit. So I am going to take one resistor, and the value of this resistor should be around mid value of this LDR. That will give us a proper matching. I need a power source also, so let me take this 9-volt battery, and then let me disconnect it from here right now, and then I am going to connect these two resistors in series. So this one goes here, this one is connected. You can connect any terminal to positive, any terminal to negative, that is all fine. Okay, so once these connections are done, let me now differentiate. This is black color, it is on the negative side, and this can be green. Now let me connect my multimeter also. So ground for all the devices, all the components should be same. This is the first rule that you should remember, that all the grounds should be at one common point. And I am going to measure the voltage at the center terminal, which is the connection of these two resistors. Now This resistance is a fixed resistance which is around 1 kilo ohm, and this is a variable resistance. So total voltage of 9 volt is being divided among these two, and the voltage at this point will be the resistance of this LDR divided by the total resistance into 9 volt. So now we can start the simulation, but before that we should make sure that the voltmeter is selected instead of resistance, because now we are going to measure the voltage. Once I do that and I start the simulation, I can see it is 8.95. The reason, because this value is 180 kilo ohm, this is 1 kilo ohm, very negligible. As soon as you move it, now you can see somewhere in the center where both the values are almost same, the voltage is almost half of 9 volt, and if you go towards the other end, this is 500 ohm, this is 1 kilo ohm, so this is 1/3 of 9 volt. Now you can see that if you attach it with a 1 kilo ohm resistor, you are going to get voltages from 3 volt to 9 volt. Okay, we are going to use this property and make a very simple circuit using Arduino now. So I am going to drag one Arduino Uno and delete this voltage supply, and I am going to power the resistor combination through the ground and VCC of my Arduino. So this is VCC, so red color, and ground is connected on this side, which is black color. Now I am going to read what is the value here through one of the analog pins. It can be any analog pin. So here what I am doing, I am reading my analog pin. A0 is reading this value, which will be anywhere between 0 to 5 volt. So let us go to the coding side. I'll do the coding in block as well as text. I am going to say, let me delete all of this, I don't need the LED blink program. So first of all, I need some input. So what are we going to read? We are going to read analog pin. So I take it. Do we need anything else? Right now, nothing from the inputs. What do we need on the output side? We need, okay, we will glow some LED, or we will print something on serial port. That is all up to you. How do you program? Okay, so let us say print something on serial port, and we need some controls. Okay, we need to wait, and let us take one if else condition. Now how do we use if else in block programming? We have seen the text syntax earlier. So we are going to go to mathematics, and here if you see, this is hexagonal shape, so only hexagonal figures are going to fit here. So I can take either this or this, or this one also. So let me take this one, which is a conditional operator which is going to compare two values, and when you bring this near the block, a white color will highlight that now you can leave it, now you can drop it, and it will fit. So what is your value number one? Value number one is read analog pin. So bring it closer and there will be a white highlight and drop it. Okay, so we are saying if read analog pin A0, if it is connected at some other analog pin, you can choose and select, is less than. So what are the ranges for my analog pin? The ranges were 0 to 1023. Let me keep somewhere in the center around 500. Then I say print. If the value is low, that means there is more light. So I can say good morning, else I can simply duplicate this, else I'll say good night. Okay, so and do we need to wait? That is all optional. You can say that it will keep on saying good morning or good night at least for 1 second. So the program is ready here also. Serial.begin, analog read, serial.println, everything is made here. Let us hide the code and minimize it slightly on this side, and we start the simulation. To look at the serial monitor, we need to open the serial monitor. So now it is showing good night. So that means it is on the darker side. When I bring it on this side, now you can see it is showing good morning. We are on the brighter side, it is showing good morning now. When we were on the darker side, now it will keep printing good night. So this was cool working with LDRs. In the next video, we are going to talk about another interesting sensor called ultrasonic sensor. Thank you.